Hi Karthik.
Evening.
Let's wait for others also to join. So actually every day we are planning to start at 5:30 mostly. So if I'm
Okay.
not mentioning any timing, right, we are going to start at 5:30. In
Okay,
case
sir.
any changes, right? So then I will let you know. Change the
Okay.
timing.
Okay, sir. Sure. Today, Vice Park is.
Today we will start on 5. Okay. So you're supposed to join in sometime. Okay. Arun, have you started practicing on SQL? Super. Everyone joined. You cannot join. Okay, fine. Super. Let's start the class. Okay, everyone is here, right? And Deepthi has some power issue, so she won't be able to join. Perfect. Let's start with today's class. I hope everyone started practicing on SQL. Okay, so SQL, Python, and all. So if you are not started it, please start it. That's it. Without SQL, you learn any concept, anything, never gonna help you. Just practice, start practicing SQL, right? If you remember, day before yesterday, also we're discussing some join, right? That also we discussed based upon the SQL only. So SQL is that important. Okay, so just try to start with my SQL. Okay, let's start today's class. Okay, everyone ready, right? Or do we need to wait?
Yeah, ready, sir.
Okay, let's start. Okay, so till yesterday we discussed on the transformations, right? Transformations. Can anyone let me know what is transformations, types of transformations? We discussed with some good examples.
There are two types of transformations,
Hmm. Hmm.
narrow and wide.
Yes. Okay, so actually, what is transformation? What is narrow transformation? What is wider transformation? Small,
The
little bit what?
transformation is the operation applied
Hmm.
to RTD.
Applied on top of an RDD to create a new RDD. Okay. What is narrow
Uh,
transformation? What is wider transformation?
Narrow transmission, I mean, all elements are required to complete the requirement. A single presentation like, sir,
Your voice is very low, actually.
sir, 1 minute.
Yeah, Harun, Veda, Anusha, anyone? What is wider transformation? What is narrow transformation?
Operations where each of something derived from the single input partition,
Single input function. Okay, okay. Good.
requiring
Yeah.
data shuffling,
Data shuffling. Yeah.
exchange across the clusters.
Exchange. Okay. So in
Um,
which transformation exchange will happen? Data exchange.
so,
In which narrow transformation or wide transformation? Out of these two, right? One needs data shuffling, the other one do not need data shuffling. Which one need data shuffling? Which one do not need
Narrow,
data?
no shuffle.
narrow, yes, no shuffle, and data exchange.
Data?
And why, sir, data exchange.
Data. Okay, okay.
Uh, in wide, there are shuffling.
Wide, yeah, yeah. So data exchange happens in wider transformations, and narrow transformations, no data shuffling, no data exchange. Okay,
Okay.
you can compute. Compute means you can calculate. Okay, whenever I say compute, you can calculate something. You can think in that way. So you can compute on top of the partition you have. That's it. If five people have five partitions, and you can each work with in your individual task. Okay, you do not need to connect with the other persons to give the results. Okay, So that's what this narrow transformation is about. For wider transformations, you all need to work together. You need to shuffle data among yourself, so that we discussed, right? A book is written by an author. Okay, so but different authors you need to calculate. Then you need to shuffle books among yourself. Then you can calculate number of books written by an author. Right? So that's how you do it. Fine. Okay, let's start. Those are the transformations. Okay, so if you see here narrow, so each partition you will apply transformation and it will create a new partition. That's it. But here you need to shuffle the data. Okay, shuffling happens, and then you are able to do. I mean, you need to apply transformations or logic on top of these transformations. Okay, that's what this wider and narrow looks like. Okay, let's jump into the next important topic: action. Okay. Before that, I wanted to cover these two topics. Okay, these are very important actually. So let me work on these two topics. Then we can jump on to action. Um, okay. Okay. So let's see what is coalesce and what is repartition. Okay. So let's say let's say I have five partitions. Okay. I distributed those five partitions among yourself. Five partitions. Now Anisha is absent. Sorry, not Anisha. Deepti is absent. So Deepti is absent for the class, right? That means there are only four people, right? Now I need to reduce my five partitions into four partitions, right? Because I have one executor less. Deepti is supposed to an executed task that was given by me, but she was not there today. That means I need to go one partition less. I mean, I need to have one less partition, so that you four can handle those partitions, right? I need to divide that one task into um, one task into I need to distribute that one task among yourself. You always have your own task, okay? But this one single task, right? I need to divide the task among yourself. So that's what I need to do. So I need to reduce the task here. Right? To reduce the task, we will go with the colis. Okay, even repartition can do the same thing. Okay, but we will go with the colis. Okay, just see why colis versus repartition. I will let you know. But yeah, just remember this: to reduce the task. Okay, to reduce the partitions, number of partitions, we will go with the colis. Okay, if you wanted to increase the number of partitions, okay, maybe tomorrow someone joins the class. Okay, today we have five people till now. Okay, but there was some x person joined the class. Okay, that means six persons. Now I need to make these five partitions into six partitions. That means I need to take some records of from each partition and give it to the sixth person, so that he can work on top of that partition, right? So that's how we will do actually, like in real time. Now let's see how things happen in the Spark side. Okay, let me go and open Excalibur. Okay, perfect. So let's see. This is one partition. Okay, this is second partition. This is third partition. Okay, this is fourth partition. Today we have this. Okay, let's go with five partitions. Okay, these are the five partitions I have. Okay, now with these five partitions there are records. Okay, R1, record 1, record 2. Okay, let's go with record. That's it. R3, R4. That's it. R5, R6, R7, R8, R9, R10. Perfect. These are the five partitions you have. Okay. This is P1, P2, P3, P4, P5. Okay. Now I wanted to reduce this number of tasks into four tasks. Okay. Now if I go with colis, okay, you guys will tell me which one is better. I will give you two options. Okay, repartition to reduce. Okay, increase. You have only one option. Go with repartition. That's it. Okay, 80. Okay, repartition. Now, if I do the colis, what happens is, let's say if you out of these five, I need to make it to four. What happens is it will take these four partitions as is. Okay, four partitions as is. This is the one partition it left, right? Come on, till here. Fine. Okay. Now these are the one, two, three, four, five. Let's go with this. P1, P2. Okay. Partition two. P3, P4. This is very important concept. Okay. P5. Fine. Let me delete these things. Okay, fine. Okay, now P5. Now this colis, what it will do is, it will take this it will take this partition as this, this partition as this partition, this partition as this. Now this one partition, right, what it will do is, it will take this R9, okay, R9, and put it into any of these partitions. Okay, just it will, let's say it will take here, okay, R9, R9. Okay. Now again this R10 is left, right? Now this R10, right, it will take any of the, it will pick any of the randomly anything. I wanted to go with P1, go with P1. If you wanted to go with P3, go with P3. If you wanted to go with P4, go with P4. Okay. Any partition. It will randomly pick any partition, R10. That's it. Now there are 10 records in this partition, in this entire task. Okay. I just divided those tasks among yourself. Okay. Two each, two partition, two records for each of the partition, for each of the persons. Okay. Now this, what police will do is, police police of 4. Okay, earlier you have 5 partitions, but here I'm just going with 4. That means, let's say, let's call this as a data frame. Okay, always remove this data frame. Data frame means this entire data we call as a data frame. Okay, data frame dot police of 4. That means number of partitions you have, it will be divided into 4 partitions. Okay, 4 partitions. And how this distribution is done is, it will take this partition asterisk, this asterisk, this asterisk, this asterisk. I mean, it won't disturb these 4 partitions. Only this partition, right, it will shuffle the data here and there. That's it. It will pick any of the data partition, P1, P2, P3, 4, among these things. It will pick any of one and just shift the data there. That's it. Very simple. Okay, let's see how repartition will do this. Okay, again, data frame dot repartition of 4. Now what happens here is, let's take 4 partitions first. We'll take 4 partitions. Okay, 4 partition, 3 partition, 4. Don't bother about the sizes. Okay, I just give them. Okay, now what it will do is, what repartition will do is, it will never pick this partition as this, as this, as this. No, what it will take is, it will shuffle the entire data, and what it will do is, it will create R1, R2, R3, R4, R5, R6, R7, R8, R9, R10. Okay, it will take entire data and it will do random shuffling. Random shuffling in the sense, it will pick, let's say, R1. Okay, it will take R1 and put it somewhere here. Okay, and in the same partition, it will put, let's say, it will take R2 and give R2 here. It will take R3 and give it here. Some all the shuffling, it will do all shuffling. All the shuffling means it will do a full shuffle. Okay, it will shuffle entire data. See, is there any reason for this repartition, right? Repartition to go and pick this P1, it could have left it as is, but repartition won't let it happen. Okay, it will take entire data and do the partitions. Okay, and here R5, till R5 we are here. Okay, so it will go to R6, sorry, R5. Okay, it will go here and put R6 here. Okay, it will go and see R7 here. Okay, it will go and give R8 here. Okay, now R10 can be anywhere, R9 right now, R9. Okay, now R10. See, this is how the partitions look like, the data frame dot repartition of 4. If I did the same with Colis is very good, right? It's very reasonable. Took the partition P1, P2, P3, P4 as this, and for P5, right? P5, we take this R9 and put it here in P2, and R10 already taken and put it into P4, right? Very simple. There is very less shuffle, right? That means there is no data transfer between the people. Like, let's say you people, right? Like you are 4 people. Okay, currently there is, I need to give the task of Deepthi to you. Then you people thought, right? Okay, I will just go and take, I will keep my task as this, and I will just take Deepthi's task. That's it. But here, what repartition will do is, it will say that no, 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 I won't take Deepthi's task. I want every task to be reshuffled and reassigned. Okay, so that's how it happens. So all the records are right, they are reshuffled, fully shuffled, right? Fully shuffled. You take entire data and shuffle the data among these partitions, right? That means there is full shuffle. So that's why whenever you wanted to go with the reduced number of partitions in your business cases, right? If you wanted to reduce the number of partitions, always go with colis. Okay, If you wanted to increase the partition size, then just go with the repartition. Okay, never go with repartition if you wanted to decrease number of partitions. Okay, for now just remember that. But there could be cases where colleagues cannot help you. You might need to go with repartition. Okay, there could be cases, but yeah, for now just remember that only collies. I will go with collies if and only if I need to reduce the partitions. I will go with repartition if and only if I need to increase the number of partitions. Okay, so far clear? Any doubts? Anyone? Any doubts? What do you understand about this collies versus repartition? What is partition first thing? Anyone let me know? What is partition first thing? How do you create a partition? Hello?
Partition is a query optimization.
No. How do you create a partition?
Okay, okay.
When will partition get created? When you read the data, what will happen? See, if you answer something right, then I will understand. Okay, you what you guys are up to.
So
So
the data shuffling,
data shuffling.
each data shuffling.
What happens when you read the data? You read some data
So,
set. How what happened to the data? We have seen many use cases, right? We have seen many use cases, many things. What happened to the data? The moment the data is read by the Spark, how it will create partitions? What is partition? Seems you guys are never going through these documents, uh, material, right? Study material. You have gone through. You might have remember all these things, but yeah, since you're not going through them, at least you're not going through this means at least you're doing any other thing like SQL practice, something, or it's very difficult for you to practice these things. So that every day in the starting rate 15 minutes you will we can dedicate to revise the concepts again and again. Speak up so I can understand. Like you guys are understanding Spark, right? Or it's very difficult for you Spark. I think till now we never entered to the advanced concepts. It's at very basics and we have gone with some very normal examples. Hello, anyone? How is Spark till
yes.
now? Yeah, Arun. How is Spark till? You guys are understanding right Spark? What is Spark? How
Yes,
Spark
sir.
work? All these things. Right? Then, like, how Spark create? I mean, what happens when you read the data? What is the first thing that will happen?
So it will break down into pieces, sir.
Okay. What we call? What was the name of that pieces? What do we call them?
A representation, something.
Sorry,
So, repartition.
repartition. Oh, so the moment it breaks into pieces, right? Those pieces we refer to as partition. First thing, that partition. Let's say it break into five pieces. That means five partitions. Okay. So the moment you read the data, first thing it will break into pieces. Fine. Those pieces we call as a partition. Super. Next. Next, what happens? These partitions will be like next. They are into next stage, right? We discussed stages, right? Stage one, stage two, stage three, stage four, like that. So what happens in the next stage? Just take any some example and just let me know what happens. Once Spark read the partition, what happens?
Write the dash to
We
write the
load the data.
storage.
Sorry, we'll load the data.
Yeah.
Okay, we'll load the
And
data
the
and then
Spark
Write
will split it.
okay. Yeah, you can go one after another. Yeah. Who is saying that? Veda or Anusha?
I was saying Vida.
Veda. Yeah, yeah, yeah. Yeah, tell me Veda. So,
So when you load the data, Spark will split it into partitions.
okay. Partitions, perfect. Then,
Then executor
mm,
um, Executor will work on
those
one,
partitions. Okay.
yeah, those partitions parallel, right?
Okay. Parallelly. Yeah.
That example you give P1, P2, P3 something.
Yes. Yes.
Um, so if the data set is 1, 2, 3, 4, 5, 6 something,
Okay.
then P1, if we take three partitions, so 1, 2 will be in P1, 3, 4
Okay.
in P2, and 5, 6 in P3.
Okay.
Um, that is about partition, whatever
Okay.
I said.
Okay.
Then repartition is it is used to increase or decrease like the number of
Hmm.
partitions.
Partitions. Exactly. Yeah.
Then
So.
does not always shuffle like fully shuffle
Hmm.
uh, across the executors like, but
I mean, will
if
it do that shuffling or it won't do that shuffling? You mean?
no, it will do the shuffle, not I mean sorry,
Hmm.
like it will do the shuffle,
Okay.
or it will always do the like full shuffle of data across the executors.
Okay. So always do the
And
full shuffle. Yeah.
mm,
Collies.
then
Will collies do the same?
colleagues will you will like avoids full shuffle,
Avoid full shuffle.
like it will merge the like it will merge the partitions, like it
Okay.
is used to decrease the number of the partitions.
Okay. Perfect. Perfect.
It's reshuffle, right?
Yeah. Just give me a minute. I'm getting it. I'll just. Fine. Okay. So actually, I have something. Something I need to attend that call. Actually, I'm in some emergency. So what I will do is, till now we covered only. We haven't covered actually. We haven't started. I just started. I got this call. Okay. I will let you know. Like currently, we can wind up. And I will let you know if I have another 30 minutes. Right. Then I will call you. I can post in the group. I'll post in the group so that we can connect. Okay. Sorry for the inconvenience, but I need to take this call. Okay.
Okay, sir. Okay, okay, sir. No
Okay,
Okay,
sir,
so
no problem.
Thank you.
Okay, thank you, sir. Thank you.
Thank you.
thank you.